I have found this method very easy, simple, and less time consuming as compared to other methods, and there is a less chance of mistake in this method. In this method, I will use this cheat sheet, and if you have an open book exam, you can take your notes and books along. You can simply have a print of this cheat sheet. It will be helpful to solve the subnetting questions. And if you don't have the open book exam, and you can simply write this cheat sheet in 3 to 4 minutes before attempting the subnetting questions. It is very easy. In the first row, I have written numbers starting from 0 till 7. In the second row, these are simply the 2's power. 2's power 0 is 1, 2's power 1 is 2, and in the last I have written 2's power 7, which is 128. In the third row, I have written 128 under this 128, and then adding 128 with 64, it becomes 192, and then 192 plus 32, it becomes 224, and in the last, if we add 254 with 1, it becomes 255. In this portion of the cheat sheet, I have written numbers starting from 0 till 12. You can also extend it to 20 or 15, whatever you like. And in the next column, I have written simply the 2's power. 2's power 0 is 1, power 1 is 2, 2's power 2 is 4, and then in the last we have 2's power 12 is 4096. In this column, I have written this third row in the reverse order, starting from 255 till 128. Now coming over to the question. Here we have given an IP address 1050.229.66 with a CIDR notation, which is classless interdomain routing, which is /23. Now to solve this question, we will pick this /23. If we divide 23 with 8, we know that 8 2's are 16. We know that IP address is a 32-bit number with 4 octets, and each octet has 8 bits. And if we have here in the question /23 and we divide it by 8, 8 2's are 16. It means that first 2 octets completely reserved for the network, 16. Then if we subtract 16 from 23, the answer is 7. Now in the third octet, we have 7 bits reserved for the network. We have calculated this 7 from this /23 notation. Now in the third octet, we have 7 bits for the network. We will use this cheat sheet. We will calculate it from the left side. We will count 1, 2, 3, 4, 5, 6, and 7. Here at 7th position, we have the value 254. We know that first 2 octets completely reserved for the network, all 16 bits. So for the first 2 octets, we will write 255.255 dot. For the remaining 7 bits, we have calculated 254 from this cheat sheet. We will write 254 here. .0. So this is our subnet mask. Now, from this slash 23, we have worked out that we are working in the third octet. Third octet, here we have the number in the given IP address, we have the number 229. Now, for the network ID, we will use this cheat sheet. Now, in the third octet, we have a subnet mask 254. We will find 254 here. Here it is written 254, and the block size against this 254 is 2. This 2 means that our network ID will be a number largest multiple of 2 which will not exceed 229. It is 228, largest multiple of 2, because we have block size 2 here, largest multiple of 2 that does not exceed 229. So we will write network ID here 10.50. From where we have calculated this 10.50? From the given IP address, because it is fixed, we cannot change it. 10.50 dot. Now the largest multiple of 2 that does not exceed it, that is less than 229 is 228. 228.0. For the last octet, we have written 0. So this is our network ID. Some people call it subnet ID. Now the next network will be, simply add 2 to this 228. That will become the next network ID 10.50.230.0. Broadcast ID, we will write here 10.50.229, because this IP is starting from 228.1 till 229.255 fall in this subnet. The first usable IP address, we know that if our network ID is 228.0, the first usable IP address will be 10.50.228.1, and the last usable IP is less than the broadcast address. We have broadcast here 229.255, and the last usable IP will be 10.50.229.254, and the wildcard. For wildcard, you simply subtract this subnet mask from 255, 255, 255.255. The first octet will result 0. In the second octet, 255 minus 255 is 0. In the third octet, 255 minus 254 will become 1, and in the last octet 255 minus 0 becomes 255. So this is how you calculate the required values. Here we are given a network address that is 172.31.0.0. The question is what subnet mask you will use to get 3540 subnets and 10 hosts per subnet. In this question, we will pick this 3540 number to solve the question. Now, if we use this column and we see that where this 3540 falls, we see that it is over this 2000 figure. It falls in this column, in this 4096 cell. Here we see that if we need 3540 subnets, then we will use 12 bits for the network address. We already have 16 bits reserved for the network. 16 plus 12, if I write here 16 plus 12 is equal to 28. We already had 16 bits. We calculate it from here. All 16 bits are reserved for the network address, and from the remaining bits, since we need 3540 subnets, it falls here. We will use 12 bits from the remaining 16 bits for the network. So 16 plus 12 becomes 28 slash 28. The slash 28 is the CIDR notation, which means that all 3 octets are reserved for the network. 8 3s are 24, and from the 4th octet we have 4 bits reserved for the network. See, so we have 4 bits reserved for the network. So we will see that where the 4th bit comes. We will calculate from the left side. 1 2 3 4. So the subnet mask will be all 3 bits reserved 255.255.255. All 3 octets, first 3 octets reserved for the network, and from the 3rd octet 4 bits are also reserved for the network, and for the 4th bit we have seen here 1 2 3 4. Here we see 240. We will write 240 here. 240.0. If we use this subnet, or the CIDR notation is slash 28. If we use this subnet, then we can have how many? 4096 subnets. We will have 4096 subnets. Now for the hosts, how many bits are left? Here we have used 28 bits for the network address. The remaining bits are 4. If we calculate 2 raised to the power of power of 4, it becomes 2 raised to the power of 4, we can see here, is 16. 2 raised to the power of 4 is equal to 16. We know that we cannot use all these 16 IP addresses for our host IPs, because the first IP address will be reserved for the network ID and the last IP address will be reserved for the broadcast ID. So we will use 16 minus 2, which is equal to 14. So we will have 14 hosts per subnet. We can write 14 here. So we have found the answer.